Okay, now we're in business. I think, oh yeah, okay. So let me get out of this here. Okay, so as I was saying, what we'll be covering today is basically how do we name these types of compounds, right? So as I said before, the type of compounds we'll be looking at are what we call covalent compounds. And covalent compounds basically are formed between non-metallic elements. So let me just make a note here, which I don't think I have anywhere in this PowerPoint here. So we're looking specifically at covalent compounds, all right? And these are compounds that are formed between non-metallic elements. All right. Now, if you recall, last time we were talking about the periodic table, and we said that there are three main categories of elements, right? We have metals, we have non-metals, and then we have metalloids, right? And if you remember, we said that the metals are to the left of the periodic table, the non-metals are to the right, and then the metalloids are somewhere in between, closer to the metal, closer to the non-metals than the metals, right? And so you can have compound formation between two or more non-metallic elements, and you can also have compound formation between a metal and a non-metal. Those are called ionic compounds. We won't be dealing with that today, all right? We're just dealing with situations where we have two non-metallic elements combining, like, for example, hydrogen and oxygen, or sulfur and chlorine, and so on, all right? And what we'll be looking at is how do we name these compounds, right? Because there are two ways of naming them. There's a common name system, and then there's a systematic name system, right? So we'll be spending more time on the systematic names because that gives us more information compared to the common names, right? So firstly, let's talk about chemical nomenclature. And that is basically, as stated here, the system which deals with the rules that you use to name compounds, right? And as I said before, you have two systems. You have the common names and the systematic names. So the common names are basically very arbitrary. You cannot tell much in terms of the composition of a compound based on the arbitrary names. Typically, the arbitrary names is a reflection of some property that could be observed about the compound, all right? Okay, what's going on here? All right, so they're not based on the composition of the compound. They're based on some sort of property that one can observe, be it chemical or physical. But in chemistry, we prefer to use systematic names, right? Because there are some rules which are much more rigorous in terms of naming these compounds, such that you can basically tell, based on a name, the composition of the particular compound. You can tell how many atoms of each element that is present per molecule of the compound, all right? So as stated here, the systematic names basically will identify precisely the chemical composition of the compounds and the organization responsible for coming up with the rules. It's an international organization known as IUPAC, International Union of Pure and Applied Chemistry. And as I recall, there is actually a division, I don't remember the name of it, like a committee that they have set up where they meet, I think, every 2 or 3 years. And the only purpose is to come up with rules concerning naming compounds. And the reason why this is necessary is because every year new compounds are made, right? And sometimes the new compounds that are made are such that the rules that are currently in place is not sufficient to name these compounds. So these guys have to meet ever so often to revise the rules or change the rules or remove rules or whatever, right? So the rules that we'll be following here are the rules as outlined by this organization, all right? Now, just to give you an idea as to what we're talking about when you compare the common names to the systematic names, right? Here we have a list of compounds. Now, these are the formulas, right? These are the formulas that gives you the composition of each of these substances. Over on the left, you have the common names, and over on the right, you have the systematic names, right? And even though I've not introduced to you the rules yet, you should be able to see differences in terms of the names on the left and the right, right? Even though you might not know the rules, I'm willing to bet that you can look at some of the names right now, the chemical names that is, and you have some idea as to what the compound is made of. So for example, let's say I choose this one here, iron disulfide. Without even knowing the rules, which we're going to get into, you would come to the conclusion that, well, this particular compound contains iron and sulfur, right? And that's basically how the systematic names is more useful compared to the common names, all right? The common names basically, as I said before, give some ideas to the type of properties that they display, right? But they don't help you in terms of the composition. Okay, so that's just, just to give you some examples of the side-by-side comparison between common names and chemical names. Okay, now let's start off with elements by themselves, right? The formula for most elements is the symbol for the element, right? So basically, if you're given information about a reaction taking place for an element, then basically you can use a shorthand representation, which would be the symbol as given in the periodic table. So these are just a few examples of that. Now, there are some elements that exist as what we call diatomic molecules, right? And there are 7 of them actually, right? So basically what this means is that in nature, right, they exist as 2 atoms in 1 unit, right? So for example, hydrogen, as it exists in nature, consists of 2 hydrogen atoms in 1 unit, 1 molecule, right? And the same is true for the others: nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, all right? So I would strongly suggest that you memorize these, that they exist as diatomics, right? And then we have 2 elements that exist as what we call polyatomic. In other words, more than 2 atoms per molecule. And here they are: sulfur, which exists as 8 atoms in 1 molecule, and phosphorus, which exists as 4 atoms in 1 molecule. And again, you need to memorize these as well, right? So you need to memorize the 7 that I gave you earlier as diatomics, and then these here as polyatomics: sulfur 8, phosphorus 4. All right. So that's basically how we deal with those elements. Now, when it comes to molecular compounds, and we're going to limit our discussion here to binary molecular compounds. So what does that mean? That means that basically there are 2 elements per molecule, right? So we're going to look at the rules for naming these compounds, binary molecular compounds, right? First thing you need to remember is that binary molecular compounds are made up of nonmetals only. So there are no metals present, right? So like I said before, hydrogen combined with oxygen, or sulfur combined with chlorine, or phosphorus combined with bromine. These are all examples of compounds that would be molecular and binary, all right? So here's a rule of thumb when it comes to naming these compounds. Well, one rule of thumb, right? Whenever you have 2 elements, non-metallic elements combining with each other, in terms of the name and the formula, the one that is furthest down and to the left of the periodic table is named first, all right? So for example, just to pick 2 arbitrary examples, let's say you're looking at a compound that is formed between carbon and oxygen, right? If you look at the periodic table and look at the positions of carbon relative to oxygen, you see that carbon is to the left and oxygen is to the right. So therefore, when you're writing down the formula for the compound formed between carbon and oxygen, carbon will be mentioned first in the formula and then oxygen, right? Or let me choose another example. Let's say you're looking at a combination of, let's say fluorine and sulfur, right? So if you look at the position of fluorine in relation to sulfur, you see that fluorine, or I should say sulfur, is to the left and down, right? Compared to fluorine, okay? So therefore, any compound that is formed between sulfur and fluorine, you'd mention the sulfur first and then the fluorine after, all right? So that's one important rule. There's some instances which I won't get into where the opposite may be true. In fact, I'll mention one. Let me see. One that is very common, exception to what I just said, is a molecule known as ammonia, where you have the nitrogen first. It's made up of nitrogen and hydrogen. Nitrogen would come first and then hydrogen, but that's one exception. Yeah, that's one exception. Pretty much, I can't think of any other exceptions, to be perfectly honest, but I'm quite sure they are. But pretty much what I just said is the rule of thumb that applies, right? The element that is furthest to the left and down in the periodic table would be the one that is written first. And you'll notice I said here, that is the more metallic element. Now, metallic is a bit of a misnomer, but what they're saying is that the element that is furthest to the left and further down in the periodic table tend to behave more like a metal than the other element. All right, that's basically what we're saying. So that's the rule of thumb that we are going to apply when it comes to naming these compounds. All right. Another important aspect of naming these compounds is the use of what we call prefixes. The prefixes are useful for indicating the number of atoms of the particular element present per molecule, right? So prefixes are very important in terms of indicating that. However, there are two exceptions where you do not use prefixes when it comes to binary molecular compounds. One exception is mentioned here. If there's only one atom of the first element in the formula, there are no prefixes used, right? So if the first element in the formula has only one atom, then you do not use the appropriate prefix, which would be mono, right? We're going to get into the prefixes later. Another exception, which I don't have here, so I'm going to write it down here, is that if hydrogen is the first atom in the formula, then no prefixes are used whatsoever. No prefixes are used. Prefixes are used. All right, so that's the other exception, right? So you might call this exception 1, and this is exception 2. All right, so that's one exception, but pretty much in all other cases, you have to use the prefixes to indicate the number of atoms of each element. Now, the prefixes that you'll be using are these right here, right? Mono for 1, and you may have met these prefixes before in other contexts, right? Di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona or nona for 9, and then deca for 10. And for our purposes, we're going to stop here. You can actually get beyond 10, but for our purposes, we're just going to stop at 10, right? So these are the prefixes that we have to use, of course, with the exceptions that I may mention before. As I said before, mono, we don't use it if the first element represented in the formula has only one atom of that element in the formula, all right? And also if hydrogen is present as the first element, then there's no prefixes used whatsoever. We're going to see some examples of this shortly, all right? But you need to know these prefixes, right? These prefixes, you need to commit to memory, right? Because this is what you're going to apply to naming these binary molecular compounds. And they're very important because they indicate the number of atoms of the particular element in the molecule of the compound. Okay, can I move on? You're writing this down? All right. Okay, so we're going to go straight into some examples right now. So let's look at this molecule here, N2O3. This is the molecular formula here, right? So the question is, how do you name this compound? Well, you'll notice that there are 2 atoms of nitrogen and 3 atoms of oxygen, right? Oh, there's one thing I should have mentioned. I just realized something. Hold on, let me see if I okay, I didn't mention it. How could I miss that? Okay. Okay, you know what? I'll go into the example and explain what is missing. All right. So as I said before, there are 2 atoms of nitrogen and 3 atoms of oxygen. All right. So basically, we have to indicate the number of atoms of each element present, right? So as stated here, that indicates 2 nitrogen atoms. That indicates 3 oxygen atoms. All right. So the name of this compound is dinitrogen, because you have 2 nitrogen atoms here, and then trioxide. Now, this element here is oxygen. This is what was missing from the notes earlier. We have oxygen here. We don't use the full name of this element in the second element in the formula, or the second name in the formula. So instead of saying trioxygen, we say trioxide, right? And this is basically what you'll observe in each case, right? The second element in the formula, the name will end with IDE, right? So you're going to use the full name for the element indicated in the first element indicated, but for the second element, its name always ends with I. You're going to see some examples of this, right? But this is basically the name of this particular compound, dinitrogen trioxide, all right? Here's another example. Now, in this case, if you remember the rule I mentioned before, if the first element in the formula has only one atom, then we do not use the mono prefix, right? So in this case here, we have one phosphorus atom. In this case here, we have 5 chlorine atoms. So the name of this compound would be phosphorus, right? And then penta, because you have 5 chlorines, and then chloride, right? Instead of chlorine, we have chloride, all right? So the name of this compound is phosphorus pentachloride. And please note, the name is not monophosphorus pentachloride. Excuse me, because of what I said before. There's only one atom of phosphorus, and therefore we do not use the mono prefix to indicate that there's only one atom for that first element. Any questions so far? Any questions? Any questions? Okay, let's see if you can do this one. So what say you is the name? What's that float? I left my water upstairs. What say you is the name of this compound?
Dichlorine heptoxide.
Exactly, absolutely right. Dichlorine heptoxide. Now, let me just say that in the case of something like this, in some textbooks, you'll see heptoxide without the A. According to IUPAC, that's fine, right? So you can say heptoxide and or heptoxide. And there's another example. I think pentoxide and pentoxide is also allowed. And hexaoxide and hexoxide. Yeah, those are allowed. So in some cases, in some textbooks, you see no A here. According to IUPAC, that's fine. All right. So you won't lose points if you do it that way. Okay, let's look at some other examples. So what do you think the name of this compound is? What? Dichlorine. Right, you use the full name of the element for the first element. So it's dichlorine and then what? What's a prefix for 3? Trioxide, exactly. So it's dichlorine trioxide, all right? Okay, very good. What about this one? And by the way, this is chlorine. This is not an I, it's an L, all right? So what would be the name of this particular? Carbon tetrachloride, exactly. Okay. What about this one?
That's carbon monoxide.
Carbon monoxide, exactly. This is, in your textbook, they mentioned this as one of the pollutants that that you might be exposed to as a result of incomplete combustion of fuels and so on.
Just had those sensors replaced.
What's that?
We just had those sensors replaced too.
You mean at home?
Yeah.
Oh, okay, yeah, right, yeah. Yeah, and it's of course, poisonous and odorless, which makes it even more, dangerous. I haven't heard about much carbon monoxide poisoning down here, but I used to live in Maryland, and in the Northeast, there's always some news about, I think his furnace is not working, and I remember there was one whole family that was wiped out, like they were just sleeping and they just all died sleeping. And that's because carbon monoxide reduces the capacity of the blood to transport oxygen, all right? It's a long story, but basically the molecule will displace oxygen when it hits the iron of the hemoglobin molecule. Okay, what about this one? Well, of course, you know what this one is, right? Carbon dioxide, right? Okay, do I have any more? What about this one? PI3. Phosphorus triiodide, right? Remember, the ending is always IDE, all right? So it's phosphorus triiodide, all right? And then, and that's it. So those are just some examples. So what we're going to do now are some more exercises where you're going to name, most of it is naming these compounds, all right? Okay, so let me give you these now. Oh, and by the way, you may have seen that I've graded your first assignment. I'm going to scan it and email it to you guys so that you guys can have it to look at. And of course, if you have any questions about any of my grading, you can contact me concerning that. But basically what this is all about, oh, and by the way, this should be chapter 2, not chapter 5, so you can correct that. So basically it's all about naming, just what we just talked about here, naming binary molecular compounds. And basically you're given, in some cases, the name and you're to write the formula and vice versa. All right. So if you have any questions, that's what I'm here for. Oh, and by the way, I almost forgot about you, Miss O'Shea. What I'm going to do for you, if I haven't done so already, I'm going to publish right now assignment, the one that I just handed out to the class. Let me see here. Oh, shoot, it looks like I don't have it here. Let me see here. I think I need to run upstairs and get my thumb drive. I thought I'd posted it in Canvas. Miss O'Shea, I'll be right back. I have to go upstairs and get my the thumb drive with that particular document, and then I'm going to upload it. All right. Okay, I'll be right back. Okay, so Miss O'Shea, let me just check here just to make sure it's there. Okay, so Miss O'Shea, you can now download it and commence starting answering the questions. Oh, one thing I forgot to mention, and that is that there are two, let me go back to my full screen. What am I doing here? Okay, let me share my screen. Let me do this. Okay, so there are two compounds that typically IUPAC basically says that you can use their common names, right? One of them is water, right? So that is recognized as an IUPAC name, right? Another one is ammonia, and that's a formula, right? So basically, if you see these two, it's okay to use their common names according to IUPAC, all right? Oops, sorry, I didn't. You were still, okay. I thought I closed that too soon. Oh, wait a minute, next week is a holiday, right? Yeah, oh, shoot, okay. Getting old. Okay, so you guys are finished? All right, well, that's pretty much all that I have for you today. Now, I've posted a video, well, actually two videos in Canvas under the module section, dealing with another important aspect which was discussed in your textbook in chapter 2, and that is the whole idea behind chemical equations and balancing them. So I want to, and it's only 2 videos I've published under that link. So make sure you watch those videos. And I was about to say come back next week, but of course, next week is a holiday. So week after next is when we're going to discuss those topics, chemical equations and balancing them.
Yeah, I do have one question.
Yes, sir.
On one of these, it says right things to program with compounds instead of O2. I'm just wondering if that's a trick question.
Okay.
Say that oxygen always has 2 atoms.
Exactly. So you can say oxygen and that's it.
Okay.
But you can also say dioxygen as another possible answer. So anyone will do.
Okay.
Yeah. Mm. And Miss, I wonder if she's still there. Miss, oh yeah, she's there. Okay. So what I'm gonna do is open up let me do that right now before I forget. I'm going to open up a Dropbox for you to submit this particular assignment. So let me do that now. Oops. Let me do that right now. It's pretty ready. Thank you. Mhm. You too. Let me see. Why is this thing not behaving itself? Hold on. Let me try this again. Let me try this again. Okay, let's see if this works. Okay, that should be it. All right, so Miss O'Shea, I've just published the Dropbox. You can submit your assignment there so that I can print it and grade it, all right? All right, so I'll see you Monday after next, since next week is a holiday, all right? Take care.